Hi, this is Dr. Graves from the CSUN Geography Department. This is a video tutorial designed to help students complete the lab called the Hollywood Arsonist, where you do some predictive crime analysis with ArcGIS online. Presumably, if you've gotten to this video, you've already read through the history of the Hollywood Arsonist and familiarized yourself with the theory behind the predictive use of statistics that we're going to try to use in order to estimate where the serial criminal lives, or at the very least, where to position law enforcement officers to catch, in this case, the bad guy through either a stakeout or a checkpoint, that kind of thing. So you've answered the questions, presumably, and now it is time to open the map project in ArcGIS Online and begin the process of analyzing the data and making some predictions about where the arsonist lives. So you click on that link, and it brings you to this web page at ArcGIS Online. Click Open in Map Viewer, and then click Sign In. Your organization's URL is CSUN GIS. Click Continue. Click California State University Northridge. And if you've already used the software, it should remember you. Otherwise, you will be asked to enter your CSUN login and password to get to this point. You should see your account information in the upper right hand corner. Once again, there are toolbars on the left that are collapsible and expandable. You want to click on the left toolbar, which is in black, and click on Layers to expand the table of contents here, and click on the right pointing triangle to expand the layers that are visible to you. The right toolbar can be expanded and collapsed once again by clicking on the button in the lower right hand side. What you see before you is the map largely that this study began with, which was a map of all of the arsons that were committed over perhaps a 2-week span. Arson investigators later found out that not all of the arsons committed during that span were committed by the same person. There were some copycat arsons. So I'm going to turn off the all arsons layer. I'm going to turn on the copycat layer for a minute, and you see these appear in light blue, and you can sort of zoom in to see how several of them were committed somewhere near Hollywood itself. We'll turn those off, and we'll turn on the actual arsons that were attributed to the eventually caught and convicted arsonist. So this is the layer. There are some other layers in the background that you need to be aware of at this moment, and one is this zip code layer that has some of the local zip codes, and you can turn that on and off as needed. So according to the principle of least effort, the person who committed this crime, and many other types of crimes would follow this, is likely to have lived in the middle of this sort of cloud of red dots that represent the criminal behavior. And so one of the easiest types of analysis to do on this is to ask the software, well, what is the average latitude and the average longitude of all of these red points that represent criminal behavior? The software will do that analysis for us. So click on Analysis, click on Tools, click on Summarize Center and Dispersion. The layer that we're going to use as the input feature is Catching the Hollywood Arsonist Web Map Arson's Actual. It's important that you use this layer. So that's in. By default, it will calculate something called the central feature, which is just the arson that is at the middle of that cloud, and it's a useful statistic. Click on the drop-down menu here and select the other three options: mean center, median center, and ellipse. And then click somewhere off that drop-down menu to hide it. One standard deviation is ideal for this. And then select an output name, and I'm going to call these central tendency. I'm going to click run, and I'm only going to click run once. It takes a moment for it to complete, 1 or 2 minutes. It's important that you don't click run multiple times. And there you see that it had just finished, and it's put several new layers on our map. You can click on the X in your Tools toolbar to get rid of it. Next thing you need to know is what are the points and that circle on the map. What do they indicate? What are they? So the central feature, that's the one in blue. I'm turning that on and off, and that represents the arson that was at the middle of all the arsons. The mean center is the green dot, and the median center is the yellow dot, and the ellipse is the oval that is surrounding most of the points on the map. The first task that you are assigned to measure the distance between the central point, the green dot, and the nearest major intersection. I'm going to demonstrate that, but I'm going to pull it to the wrong intersection, so do not use that as the answer. So I'm going to move the map over here and click on Map Tools and select Measurement. In order to do a measurement, click on the green point, the mean center point, click on it once, and then drag over to the nearest intersection. And this is not the nearest intersection of a major street. This is a further intersection, and I can zoom in and get it right there in the middle and double click to end that operation. The question is going to ask you, what about in meters? So you can change it to metric, or to be precise, change it to meters. And if I asked you to measure to this intersection, you would use 951 or 952 as your answer. Measure to the nearest intersection and enter that into your learning management system. The next task is to measure between the mean center point and the nearest suspect. I'm going to show you how to do it. You may want to turn the arsons layer off, because that makes it difficult to see the suspects. So once again, click on Map Tools, Measurement, and I'm going to measure to a point that is obviously not the answer. This is not the nearest suspect, but you could measure to that one and this one and that one and see which of those is the closest. Then enter your answer in meters into the next question. Okay, you can, for the moment, get rid of your measurement tool. What I want you to do is, under the Catching the Hollywood Arsonist web map layers, click on Standard Distance. And this is a tool that's not available on the online version, but this is the equivalent, the map or spatial equivalent of a standard deviation in statistics. Turn off the ellipse for a moment. And if all of the arsons on the map were evenly distributed in all directions from the mean center, then the standard distance circle would roughly include about 60 to 70% of the arsons inside that standard distance. But there is a pattern to the arsons in which the data is not evenly distributed. It's actually distributed in a sort of a direction which makes the standard distance circle, the red dotted one, less useful than the ellipse. It's at this point you are asked a couple of questions about the number of suspects inside the standard deviational ellipse. So you may want to make invisible the arsons and zoom in a little bit, count that number, and then there's another question about which zip code contains the most number of suspects. So you have to analyze that quickly and answer those questions. Okay, you can turn the zips layer back off. Next, focus your attention on the relationship between the mean center, which is at this point, the arsons that were actually committed, their distribution, and this point called the median center. The fact that this ellipse is stretched thin in this pattern is a byproduct of the physical environment, that the arsonist found it difficult to find suitable dingbat apartments to catch on fire, and so his behavior was stretched by the available targets. This is an example of skewing, and when you have skewed data in statistics, you use the median, and when you have skewed distribution of points on a map, you use the median center instead. So that is this yellow dot, and because the data is skewed, this is a better point, a more logical point to set up a checkpoint to inspect cars that are passing by that might contain the suspect, and it changes dramatically the likelihood of one of the suspects on the map being the actual Hollywood arsonist. So there's a couple of questions about the highway that the arsonist probably drove quite a bit and the physical barrier to the movement of the arsonist. So you can answer those, and then we're going to measure from the median center point to an intersection and the nearest suspect. So I'm going to turn off the arsons layer, zoom in on the median center point, and begin measuring. Once again, click on Map Tools and click on Measurement, and we want to select the mean center point, drag the point to the nearest major intersection. I'm going to drag it to a further intersection, double click, change it to metric, and if that was the question that I asked you, then the answer would be nearly 2,000. Then you are asked to measure to the nearest suspect, which would be something like this. Clearly that's not the nearest suspect. Choose the one that's closest. Then you're finished with the measurement questions, and then the last question asks you to zoom in on the nearest intersection, find the names of those streets that's the nearest intersection, and report it as a excellent place to set up a traffic checkpoint to look for people driving around in vehicles that smell a lot like gas. The last question asks you to pick the nearest suspect, and I'm going to pick one that's further away. Click on that suspect, the point, and report the ID number of the suspect. This is a further one away, so definitely the answer is not 3179. As it turns out, the suspect that lived closest to the median center was the actual, or very near the address of the actual Hollywood arsonist, who was arrested after being pulled over at the intersection that this exercise suggests a checkpoint should be set up, and the person was, from what I understand, taken into custody at the intersection at Sunset and Fairfax. That concludes this video tutorial.